The replicate system was developed by the Ice Drilling Design and Operations Group, IDDO, at the University of Wisconsin-Madison for the National Science Foundation. It was deployed in December 2012 to re-enter the 6.5-inch diameter borehole at the WAIS Divide. The existing, or parent, borehole at WAIS Divide was created over the past several years by IDDO using the deep ice sheet coring drill. The parent hole was completed in 2011 at the depth of approximately 3,400 meters. The replicate drill was designed to steer out of the parent hole to retrieve additional samples of core at areas of high interest. The replicate drill builds on existing infrastructure of the disc drill. The downhole portion of the drill, the sonde, was significantly modified to meet the requirements of steering out of the parent hole. In the first step of the process, the broaching cutter head is deployed to the target depth. The drill is tipped to the high side of the borehole to engage the cutters. Ice is removed in repeated passes of approximately 15 meters in the upstroke. Deviating on the high side of an open borehole is a unique and critical process. Making the deviation on the high side maintains unhampered access to the full length of the parent borehole for passive logging tools. In the second step of the process, a milling head is deployed. The milling head creates a landing for the coring head. Coring removes a 20 mm kerf and allows a 108 mm diameter core to enter the core barrel. 2 meters of core are removed per trip. In the first deviation, about 100 meters of core was removed and required about 50 trips. After the deviation was completed, we reconfigured the lower sonde one more time to install a customized high-pressure camera to record the result as a borehole video. Here, the camera is being installed. Directly in front of the camera lens is the light assembly, which illuminates the borehole when we descend. Now we fast forward as the drill is tipped from a horizontal to a vertical position. On the left, you can see the dummy logging probe on a 10-meter tether being lowered to the casing. The probe must pass smoothly through the parent hole and be unaffected by the deviation to confirm that future logging efforts in the parent hole can be performed without issue. Here we enter the plastic casing that supports the top 90 meters of the hole. You can see scratches from the nearly 2,000 trips the sonde has made in creating the parent hole and now the deviations. We fast forward through 90 meters of casing until the sonde enters the fluid. Fluid balances the hole for the next 3,300 meters and keeps the hole from collapsing. The top of the fluid column is cloudy, but clears up at lower depths. We fast forward through about 45 minutes of the descent. Now, as we near the deviation, you can see deep marks in the ice from the anti-torque levers. Finally, we reach the depth of the deviation and you can see milling marks. Initial testing left milling marks on all sides of the hole. As we descend, the smooth cut of the broaching cutter becomes visible on the high side of the borehole. Now we are near the end of the deviation. You can see it is much wider. The camera sits on the low side of the hole, so the high side is opposite the light. The deviation becomes so deep that the high side of the hole is no longer lit. Deviating on the high side of an open borehole is a unique and critical part of the process. Because the borehole is not perfectly vertical, the sonde slides on the lower wall of the borehole. Actuators lift the sonde to cut the deviation on the high side. With the deviation on the high side, the entire length of the parent borehole is accessible for future borehole measurements using passive logging tools. We continue to descend through the parent borehole. You can see the stick slip of the camera even though the cable payout is at constant speed. The gap between the parent hole and the replicate hole gets smaller and smaller as the parent and replicate holes get farther and farther apart, and finally it closes. The ledge at the end of the gap is about 2 inches wide. From this point down, the holes are completely separated. Beyond this point, the parent borehole is untouched. We stop at about 10 meters below the end of the deviation. Now we trip back up to where we can enter the replicate hole. You can see the ice chips and the cable filler, the long strands, are stirred up during the ascent. The light is on the lower side at the bottom of the deviation, and we can tip the sonde to illuminate the high side. Now you can see the replicate borehole. The camera drops abruptly, again with a stick slip. You can see the actuators react and automatically reposition the drill. We descend further into the replicate hole. We can't go too far because the logging probe is tethered and still in the parent borehole. You can see the gap between the two holes on the left side. The gap between the two holes shrinks. The replicate hole is diverging from the main hole at about 1 degree. And that is as far as we go. We return to the top of the replicate hole. At the top of the replicate hole, we retract the levers. The drill falls back into the parent hole. And now the 2-mile ascent back to the top to find what footage we have on the camera.